On Christmas Eve 2024, while most of the world was asleep, a machine built by human hands crossed a boundary no object in history had ever crossed. It flew directly into the sun. Not past the sun, not close to the sun, into it. Traveling at 430,000 miles per hour, fast enough to circle the entire Earth in under 4 minutes. NASA's Parker Solar Probe became the fastest human-made object ever recorded, and the first spacecraft in history to enter a star's atmosphere. And then it went silent. For 2 days, scientists heard nothing. No signal, no data. Just the terrifying quiet of deep space, and a probe swallowed by the sun. This is the story of a machine built to touch a star, a scientific mystery that baffled physicists for over a century, and a lone astrophysicist whose idea was publicly ridiculed, until the entire scientific world had no choice but to admit he was right. This is the Parker Solar Probe, and its story starts not in a lab, but with a question that basic physics said should never exist. The surface of the sun burns at around 10,000 degrees Fahrenheit. That is already a number so large it is almost impossible to hold in the mind. But the sun's outer atmosphere, a region of glowing plasma called the corona, reaches temperatures of 3.6 million degrees Fahrenheit. The atmosphere is 360 times hotter than the surface directly beneath it. This phenomenon has a name, the coronal heating problem. And for over 100 years, it sat as one of the most embarrassing unsolved questions in all of astrophysics. Every model scientists built kept running into the same wall. The math did not work. The corona should not be hot. But it is. Outrageously, impossibly hot. Researchers had theories. They had telescope observations from millions of miles away. What they lacked was a way to go there, to actually fly into the corona and read what was happening from the inside. Because the sun does not just offer up answers. It tries to destroy anything sent near it. So the real question, the one that would define this entire mission, was never just, why is the corona so hot? It was, how to build something that can survive long enough to find out. Before examining the spacecraft, it is essential to understand the man it was named after. In 1958, a young astrophysicist named Eugene Parker wrote a paper proposing something that the scientific establishment considered absurd. He claimed the sun was not a static, quiet object. He claimed it was constantly releasing a stream of charged particles, electrons and protons, flowing outward through the solar system at tremendous speed. He called it the solar wind. Parker did not walk it back. He refined his calculations, resubmitted the paper, and a senior editor, Subramanian Chandrasekhar, who would later receive the Nobel Prize in Physics, overruled the reviewers and published it. 3 years later, the first space probes confirmed the solar wind was real, exactly as Parker had described it. He was right, completely and totally right, and the establishment was wrong. 50 years later, NASA did something it almost never does. It named a spacecraft after a person, while that person was still alive. On May 31, 2017, at the University of Chicago, 89-year-old Eugene Parker watched NASA officially unveil the mission bearing his name. In the audience, watching the announcement, were some of the very scientists who had spent their careers building on the foundation he had laid decades earlier in a paper nobody wanted to publish. Parker passed away in 2022. But the probe carrying his name was already deep in space, spiraling toward the sun, on a mission to answer the very questions his work had spent a lifetime raising. Building a spacecraft that could survive inside the sun's atmosphere required solving a problem that had never been solved before. At its closest approach, the probe would be just 3.8 million miles from the sun's surface. That sounds like a significant distance, but it puts the spacecraft deep inside the corona, the same region that reaches millions of degrees. The solution was a heat shield unlike anything ever built, an 8-foot wide, 4.5-inch thick carbon composite barrier. On the sun-facing side, it would absorb temperatures approaching 2,500 degrees Fahrenheit. On the instrument side, the shaded side, temperatures would remain at roughly 85 degrees, room temperature. Inside one of the most hostile environments in the solar system. The probe launched on August 12, 2018. But reaching the sun is not a straight shot. The sun's massive gravity makes it very difficult to travel inward from Earth. A direct approach would require enormous fuel expenditure to slow down enough to stay in orbit rather than being flung past. So NASA used Venus instead. 6 times over 6 years, the probe swung close to Venus in carefully calculated gravity assist. Each flyby used Venus's gravity to bend the probe's trajectory and tighten its orbit around the sun. Each pass a little closer, a little faster, a little hotter, a little more dangerous. 6 years of patient, incremental daring. Each orbit a test the spacecraft had to survive before it could attempt the next one. The mission was not a single dramatic moment. It was a slow, deliberate tightening of the spiral. Engineers watching every data point, every temperature reading, every system check, looking for any sign that the heat shield was failing. It never did. December 24, 2024, Christmas Eve. The Parker Solar Probe reached its closest approach, what engineers call perihelion. It crossed the Alpha-Ven surface, the outer boundary of the corona, and entered the sun's atmosphere for the first time in human history. At that moment, the probe was traveling at 430,000 miles per hour. That is 119 miles every single second. Fast enough to travel from Miami to New York City in under 12 seconds. Fast enough to circle the entire Earth in less than 4 minutes. No human-made object in history had ever moved that fast. For 2 days, the probe was on its own. December 26, 2024. 2 days after Christmas, a signal broke through. The Parker Solar Probe had survived. It had flown through the sun's corona, recorded everything it could, and emerged on the other side, intact, transmitting, and carrying data that would change everything. Inside Mission Control, the reaction was immediate. Scientists who had given years of their lives to this mission pumped fists, embraced, some of them in tears, because they understood what this moment meant, not just for their careers, not just for NASA, but for the entire history of human exploration. Humanity had touched a star. The data the probe sent back did not just fill in blank spaces on a chart. It rewrote entire chapters of solar science. Here are the 3 discoveries that matter most, and why they change everything. First, the origin of the solar wind. Scientists had known the solar wind existed since Eugene Parker predicted it in 1958. What they had never seen was exactly where it forms. The Parker Solar Probe flew close enough to capture direct observations of the solar wind's origin point, the specific region near the sun's surface where charged particles are energized and flung outward into the solar system. That single observation confirmed theoretical models that had been debated for 6 decades and settled arguments that had divided the solar physics community for a generation. Second, magnetic switchbacks. The probe detected something completely unexpected inside the solar wind. Magnetic field lines that were folding back on themselves in sudden, sharp reversals, zigzagging instead of flowing smoothly outward. Scientists called them magnetic switchbacks. They were not in any model. They were not predicted. They were a surprise. And they may be the answer to the coronal heating problem. The leading hypothesis is that these switchbacks carry energy upward from the sun's surface, releasing heat into the corona as they travel. If that is correct, the mystery that baffled physicists for over a century now has a name, and it was found by going there and seeing it directly. Third, solar storms and modern infrastructure. Coronal mass ejections, violent eruptions of magnetized plasma from the sun's surface, are among the most destructive phenomena in this solar neighborhood. A powerful geomagnetic storm in 1989 left 6 million people in Quebec without electricity for 9 hours. Scientists estimate a major modern solar storm could cause trillions of dollars in damage to global infrastructure, knocking out satellites, disabling GPS, collapsing power grids, and cutting global communications. The Parker Solar Probe provided an unprecedented close-up view of how these ejections form and behave in their earliest stages. Better data means better models. Better models mean better early warning systems. More warning time means the ability to protect the infrastructure that modern civilization entirely depends on. There is something that gets lost in the headlines about speed records and heat shields and solar storms. Every star in the universe is a sun. There are an estimated 2 trillion galaxies in the observable universe, each containing hundreds of billions of stars. Some of those stars have planets. Some of those planets exist in conditions that could support liquid water. And all of them, every single one, is governed by the same laws of physics that govern this solar system. Understanding how this sun's corona works, how solar wind forms, how magnetic fields store and release energy. These are not just questions about a small corner of space. They are questions about stars at large. The Parker Solar Probe is providing a template, a framework that will apply to every stellar system ever studied. Eugene Parker spent decades trying to convince the world that the sun was not a quiet, static backdrop in the sky, that it was a dynamic, living system, violent, changeable, and deeply connected to the planets around it. The mission that carries his name is proving, in real-time data, just how completely right he was. A spacecraft launched from Earth, built by human hands, guided by human mathematics, powered by human curiosity, is now the first man-made object in history to have entered the atmosphere of a star and returned. Take a moment to hold that. It was actually accomplished. The Parker Solar Probe did not just set a speed record. It did not just send back interesting data. It transformed what it means to be an exploring species, because for the first time, humanity is not just observing a star from a safe distance. It is inside one, reading it from the inside out. And what is found there will shape everything that comes after. If this video provided a new perspective or a genuine sense of how far human ambition can reach, consider subscribing. New videos explore space science, unsolved mysteries, and the stories behind the discoveries that change everything. Leave a comment below on which part of this story stood out the most, whether it was the engineering, Eugene Parker's vindication, or the discoveries that protect modern infrastructure. Thanks for watching.